And this is a question about Nernst equation. What does Nernst equation tell you? Actually, you might be able to calculate E naught cell, but if there are cases in which we have non-standard concentrations, that means concentrations which are not 1 molar, or pressures, partial pressures which are not 1 bar or 1 atmosphere. In that case, if you record certain volume of whatever would be the EMF of the cell, that would not be the standard EMF. It might be different. And this EMF of non-standard cell can be calculated using an equation called Nernst equation. What does it say? It says, first of all, I'll just give you a very good example. Let's first write down this case for first question. Magnesium, magnesium ions, copper. Now what is anode reaction? Anode reaction is magnesium is giving me Mg2 plus 2 electrons. And at cathode, copper ions gain those 2 electrons and they give you copper. If I add up, I have Mg plus Cu2 plus aqueous giving you Cu metal plus Mg2 plus aqueous. Is that all right? Yes, of course it is. It's great. It's absolutely great. Now when I have this is the cell reaction. Write down. Can I write down the reaction quotient Q? You remember equilibrium constants and reaction quotients. If you just assume this to be reversible reaction, what would be the reaction quotient Q? Q would be concentration of magnesium ions divided by concentration of copper ions, right? And in case it is a standard cell, copper and magnesium ions both would be 1 molar each, and Q would be equal to 1. But in case Q is not 1, for example, in this case, concentration of magnesium ion is 10 to the minus 3 molar divided by 0.0001, copper ions is 10 to the minus 4 molar. Oh my God. So this is 10 actually. Yes, it's 10. Now, this is the calculation of Q. How did I get Q? First I wrote down, looking at the cell, I wrote down anode reaction and cathode reaction. I add the reactions so that electrons cancel, and the number of electrons cancelled represents N, and I get the overall cell reaction. From this cell reaction, I write down, see, for solids are excluded. They are not a part of a game. Liquids, the solution, the aqueous solution species, and the gases, they are used in writing down the reaction quotient Q, right? So we wrote down Q. How did I get this? By writing them. How did I get them? By looking at 1, anode and cathode. And once I've got Q, I've got N, all I have to do is substitute N's Nernst equation. Do I need something else? Yes, I would need E naught cell also. But before that, let me write down Nernst equation for you. It says E cell is equal to E naught cell minus 0.0591 upon N log to the base 10 of Q. Oh my God, what is 0.0591? This is RT upon F. If you take R, F and T, temperature is 298 Kelvin, this is the value you get. You substitute that at 2.303 also, of course, there, because ln has been converted to log. This is Nernst equation. Fascinating. I have N, I have Q. The only thing I need is E naught cell. Can I get that? Of course I can get that. Why? What is E naught cell? For this case, E naught cell is equal to E naught cathode minus E naught anode. Cathode is copper ions to copper, E naught of copper ions to copper minus E naught of magnesium ions to magnesium. How much would that be? Well, let's take a look. Copper ions to copper is 0.34 volts. It is not given in the question paper or in the problem here, but NCERT has given you already a list and that contains that number. This is 0.34 volts minus the value of magnesium ion E naught. You might need to check that, right? And once we have that, what do? E naught cell we have 0.0591 by 2 log to the base 10 of Q. Now Q is 10, so log 10 is 1. We just substitute that and we get the answer. Magnesium ions के लिए आप देखोगे तो value है minus 2.37. Oh my God, that's pretty high. Yes. So how much is this? This is 2.6. No, not 6 also. This is 2.71 volts. That's pretty high. Yes, that's pretty good. तो E नॉट सेल है 2.71 वोल्ट और E सेल कितना हो जाएगा, इसको यहाँ सब्स्टिट्यूट करते हैं और निकाल लेते हैं. कैसे? आइए देखिए. दिस इज 2.71 माइनस 0.0591 अपॉन 2. log to the base 10 of Q, log 10 is 1 into 1. 0.0591 अगर आपको थोड़ा अगली लगता हो, एक क्षण के लिए 0.06 मान लीजिए, 0.06 अपॉन 2 0.03 तो आएगा 2.71 में से तो 2.68 volts. This would come out to be 2.68 volts. Is that fine? Yes. This is the first part. ऐसे ही हम करेंगे second, third और fourth. Let's begin. Second part, if you look at, it says iron to ferrous. This is anode and hydrogen and H plus. That is cathode. Very interesting. Let's take a look. Now first, what is the way to solve this? First of all, write down the reactions at anode and cathode. So left side is anode. Anode is iron getting oxidized to ferrous plus 2 electrons. And 2H plus 2 electrons gives you hydrogen. If you add up, you get iron plus 2H plus gives you ferrous plus hydrogen. This is the overall cell reaction, right? How do we write down reaction quotient and N? We cancel 2 electrons, so N is equal to 2. What about the reaction quotient? Can we write down that? Of course we can. How about Q? Q is products. Product is ferrous upon H plus ka square. Square of H plus 2H plus. Solid iron is skipped and hydrogen is gaseous. What about gases? Into partial pressure of hydrogen. Wow. So we write down partial pressure for gases and concentration for solutions? Yes. Solids are simply neglected, dropped. We don't mention them at all. Okay, well, that sounds simple enough. Now, could we calculate reaction quotient Q? I guess we can. Ferrous ions are 0.001 molar each. This is 0.001 molar divided by H plus is 1 molar. 1 square into partial pressure of hydrogen is 1 atmosphere or 1 bar, which is again 1. Please remember, partial pressure is to be taken in atmospheres or bars. Both of them are reasonably close, while the concentration has to be taken in molarity, right? How much is this? This comes out to be 10 is to minus 3. So Q comes out to be 10 is to minus 3 or log Q. What about log of Q? Log of Q would be minus 3. In Nernst equation, we would come across log Q, so please note. What about E naught cell? Can we calculate E naught cell? Of course we can. E naught cell is E naught cathode minus E naught anode. What about cathode? Standard hydrogen electrode has E naught cell 0, yeah, half cell. And what about anode? Anode is iron to ferrous minus 0.45 volt. If you check the chart given in NCERT for SRP values, that comes out to be 0.45 volts. That's beautiful. That is E naught cell. And E cell would be equal to E naught minus 0.0591 upon N log to the base 10 of Q. Now log 10Q is minus 3. N is 2 and 0.0591, this is too ugly a number. If we approximate this by 0.06, not very bad. What do I get? I get 0.45. Now minus 0.06 by 2 is 0.03. 0.09. So that makes it 0.54 volts. Oh wow, 0.54 volts. Yes, that would be the EMF of second cell. But don't you forget, this is approximate because we assume 0.06 instead of 0.591. If you do it more accurately, the actual value comes out to be 0.528 volts. And how do I get this? Use accurate value. I just found out approximate. This was an approximate value which I used. If you wish to make it more accurate, this is what you are going to land up with. Done? Done. And there comes now the third option, which contains tin as well as hydrogen electrode. And in this case, hydrogen electrode is no longer standard. H plus ions have now a different concentration. How shall we do it? Let's do that. First of all, write down the reaction. Now, students consider Nernst equation difficult. Why? Because they skip the first step. And what is the first step? Writing the cell reaction. If you are good enough, if you just spend 30 seconds extra and write down the cell reaction properly, you would never find it troublesome. Also, we don't know how to write down cell reaction. I'll tell you, it's very simple. See, left side is anode, so write down anode. Now, first put an arrow, tin, solid, is giving you stannous ions. Just write down oxidation reaction. That is simple, of course. What about cathode? 2H plus aqueous plus 2 electrons is giving me hydrogen gas. Okay. Could I add this? Of course you can. Tin solid plus 2H plus aqueous gives us stannous ions aqueous plus hydrogen gas. Can you write down the reaction quotient? Yes, we can. Q is concentration of stannous into partial pressure of hydrogen by concentration of H plus to the power 2. Tin being solid is dropped. Now hydrogen, many times in different guides you will see they will skip the partial pressure of hydrogen. Please remember, partial pressure of gases should not be skipped. In NCERT, unfortunately, they have, in such cases where concentration and pressure both are present, they have assumed that only one of them varies. So even if you skip it, it doesn't matter. But accurately, this is the way you have to do this, right? And can I calculate this? Of course I can. What about stannous ions? Stannous ions are 0.05 molar and H plus ions are 0.02 squared, right? And then you have hydrogen, which is 1. Could we calculate that? Yes, of course we can. This is 5 by 2 into 50. 5 by 2 into 50, which is 5 into 25, which is 125. Oh my God. So this reaction quotient comes out to be 125? Yes, it does. So far so good. Now, let's substitute in Nernst equation. We'll need E naught cell also. What is E naught cell? I'll not write down the formula third time. We have written it twice already. E naught of cathode minus E naught anode. Now, what is cathode? Cathode is tin to stannous or stannous to tin. That is minus 0.14. Sorry, cathode is 0. This is cathode. Cathode is 0. Minus anode is minus 0.14 volts. So this comes out to be 0.14 volts. Okay, beautiful. Could we substitute? Yes, we can. E cell will be E naught cell minus 0.0591 upon N. N is 2 into log to the base 10 of Q. Q is 125. Horrible. What is log of 125? We will have to check. We'll check and see. Actually, instead of 125, if you write down 1000 by 8. These are the logarithms probably I remember. How do I remember? I'll solve it for you and show you. Log of 1000 by 8 is log of 1000 minus log of 8, log of 10 raised to 3 minus log of 2 raised to 3. Okay, that's lovely. How much is that? Log of 10 is 1, log of 2 is 0.3010. This is 3 times 0.7 approximately. If you subtract and all, it's around 3 into 0.7, whatever that comes out to be. So this is 0.14 minus 0.06. I'll just give you first approximation. 0.06 by 2 is 0.03 into 3 into 0.7. Let me see what does this give me. 3 into 3 is 0.09, 9 7s are 63. So that would make it 0.14 minus point, and how much is that? How many zeros? 0.09, 0.063. Sorry. Could I subtract that? Of course I can. 140, if you take away 63. From 0.14, if I take away 0.6, that is 0.08. 0.08. That's close to 0.08 volts actually. Because please remember, this is a slightly bigger value. We have assumed 0.06 to be subtracted while it is actually 0.0591 only. So I'll obtain close to this, somewhere 0.079 volts or something, which can be approximated as 0.08 volts, which is fine. That is the answer for third question. And there comes the fourth one. Oh my God, with a bang. And this time we have a non-metal. Bromide ions getting oxidized to bromine. Wow. Let's write on the reaction. Bromide ions getting oxidized to bromine and releasing electrons. On the contrary, who's getting reduced? Now, reduction apparently is with H plus ions. H plus ions are getting reduced to hydrogen gas. That seems awfully negative and bad. Let's take a look. It is 2 times Br minus plus 2 times H plus, giving you Br2. Br2 is of course liquid, plus hydrogen, which is gaseous. Now please note, bromine liquid is a pure liquid. It is not something which is soluble in water much. So if they are clearly writing Br2 liquid, it stays as Br2 liquid, and pure liquids and pure solids are not considered while writing reaction quotient Q. So Q would be simply how much? Partial pressure of H2 gas, which is actually 1 bar, divided by concentration of H plus square Br minus square. Oh my God, and how much is that? That is 1 bar divided by how much is H plus? 0.03 and Br minus 0.01. So 0.03, 0.01. Fancy. What would that be? This is 10 raised to 4 upon 9. Oh, ugly. Can we take log? Yes. So log 10Q, because we often need this, is log of 10 raised to 4 by 9, which is log of 10 raised to 4 minus log of 3 square. 9 is 3 square. Power can come out. 4 log 10. Sorry. And log of 10 is 1. This is 4 minus log of 3. 2 times log 3. Log 3 is 0.4771. 0.4771 into 2. This is 0.9542. Cheap and ugly, whatever it comes out to be. How much is this? This is 3. God save me, whatever, 3.0458. This is the value of Q. Why have you calculated Q? I'm also supposed to calculate E naught. Let me calculate E naught cell also, which is E naught cathode. How much is that? 0. Minus E naught anode. Now bromine to Br minus. Reduction potential of bromine is 1.09 volts. How do you discover this? It is in the chart given in electrochemical series of NCERT. You can see the value from there. What about exam? If it is asked in exam, E naught values will have to be given to you. Obviously, you cannot discover them on your own automatically. So this is, now reduction potential is 1.09 volts. So oxidation potential, now this comes out to be minus, this is minus 1.09 volts. Horrible. E naught cell is so negative. That means this doesn't look like a spontaneous reaction. Of course, it is not a spontaneous reaction, but we are just supposed to find E naught cell, that's it. And E cell, so we'll just find that, even if it's negative. So, E cell is E naught cell minus 1.09 minus 0.0591 upon 2 log to the base 10 of Q. Oh my God. And that is 3.046. This is 3.046. Let me make more hectic calculation. This is minus 1.09. Yes. And minus 0.0591, God save me, into 1.523. Lovely. So loving, so delicate. It is getting more and more negative. And this is minus 1.298 volts, roughly minus 1.3 volts. This would be E cell for the final and the fourth part.